Welcome, this is the IM2 video lecture on factoring ax squared plus bx plus c when a equals to 1 part 2. The learning target is the same. It's for you to learn how to factor this trinomial of ax squared plus bx plus c. The success criteria is, can you find a, b, and c from standard form of a polynomial? And to use the diamond method to factor. It's the same thing as part 1. I just want to give a little bit more clarification. First, we have to isolate a, b, and c. A is 1. If you would like to see where that comes from, it is the leading term. It is the number in front. Right there. There's a 1. The b is the 4. It is the number in front of the x right here. And lastly, it's the c. It is the constant. If you put positive 12, it is wrong. Please understand that the c is the constant term. It is the whole thing. So that negative is part of that number as well. Step 2 is for you to draw and fill in the value for the diamond. The left hand side, b equals to 4. That is when b is equal to the two numbers that will add to make 4. And on the right hand side, it's the negative 12. You're going to find two numbers that multiply to make 12. Next, to do this, you want to find p and q. So, like my suggestion is to make a list of factors. The list of factors are 1 times 12. How did I get that? Well, automatically, to make 12, you can just divide it by 1. That gets you 12. Now, on Desmos, I just put 12 divided by 2. That makes 6. So I can go 2 times 6. 2 times 6. Then I can do 12 divided by 3. You see how that got me 4? So I can do 3 times 4. Right? That's how I make my list of variables using a calculator. I just grab the number and start dividing, starting from 1. Divide by 1, then divide by 2, and only look for whole numbers. So now I want to pick what two numbers that can multiply to make negative 12 that adds to 4. I take a look. Maybe 2 and 6 looks right. So I can now try it. Well, I want to make negative 12. So one of these numbers has to be a negative. So I'm going to go negative 6 times 2. This gets me my negative 12. So this works. Now I add them. Negative 6 plus 2. That gets me negative 4. Does that work? No, it does not work. That negative was in the wrong spot because I still got the value of 4, but I wanted positive 4. So let's try that again. I decide this time to put the negative with the 2. So I went 6 times negative 2. That still gets me negative 12, so that checks out. Now I add 6 plus negative 2. This gets me my 4. That checks out. So my factors are p is 6, q is negative 2. At this moment, I can now put it in factored form. It can be x minus 2 as well as x plus 6. This is factored form. If I would like for it to now, after this, step 3 comes. Step 3 is if the question asks you to solve for the polynomial. To solve for the polynomial, you have to set each factor equal to 0 and solve. Okay, so x minus 2 was the first factor. We set that equals to 0. To solve for x, you add 2 to both sides. Then you get x equals 2. The second factor was x plus 6. We set that equals to 0. To get x alone, we subtract 6 to both sides. You get x equals to negative 6. At this moment, we say that x equals to 2 and x equals to negative 6 as the solution to this polynomial. X equals to 2 and x equals to negative 6 are the solution. What you have here of x minus 2 parentheses, x plus 6 parentheses, this is called your factored. Okay, that's the difference between factor and the solution. Alright, so the steps are the same as part 1, but now I am throwing in the last part, which is finding the solution. Make sure you take down these notes. Let's do this first example. Here, we look for a. A is 1. It is the number in front of the x squared. Then we look for the b, which is the number in front of the x, which is negative 13. Then we look for the c, which is the constant term, which is 40. We plug it in. B equals to negative 13. C equals to 40. Now we say to ourselves, what two numbers multiply to make 40 and add to negative 13? Let's write our list here of factors. And we know we can always start with 1 times that number, which is 1 times 40. So let's take a look. So 40 divided by 1, that works. Let's divide this by 2. So 2 times 20 gets us 40. So let's write that. 2 times 20 gets us 40. Let's try 3. Let's divide this by 3. Oh, it's a weird fraction, so we don't say 3 is a good number. Let's try 4. 40 divided by 4 is 10. So we write 4 and times 10. That looks good. Then we try 5. 5 and 8 is good. Notice the numbers keep coming towards each other. Let's try 6. 6 times 6.666. Nope, that's not good. So these would be your different factors. Alright. Now I want to make sure that all these numbers can multiply to 40. But let's see which one can add up to negative 13. It's a negative, right? So let's see. 1 and 40 doesn't look good. 2 and 20 still doesn't look good. 4 and 10 looks good. And 5 times 8 looks good. Let's try 4 times 10. Let's see if that one worked. Alright. Okay. So I can write C is equal to 4 times 10. That gets me my 40. So that works. So that checks out. Let's try this. 4 plus 10. That gets me my 14. That doesn't work. What about if I make them both negatives? Negative 4 times negative 10. So here it would be negative 4 plus negative 10. Does that work? No, that still gets me negative 14. So that wasn't a good choice. Right? I wrote it out so my brain can see it. Let's try 5 and 8. So 5 times 8 will get me my 40. That's perfect. Now let's try 5 plus 8. That got me 13. But I want it to be negative. So maybe I made both of them negatives. So negative 5 plus negative 8. That gets me negative 13. So that checked out. So let me go back here and double check on this side. Negative 5 times negative 8. That still got me my 40. So that checks out. My two factors here, P equals to -5, Q equals to -8. So I can say X is, my factors would be X minus 5 parentheses, X minus 8. Now we want to solve for the polynomial. So what I do is I set the factors equal to 0, then solve. Let's do that. Okay. I have X minus 5, set that equal to 0. I have to add 5 to both sides. I get X equals to 5. The other side, I have X minus 8 equals to 0. I add 8 to both sides. I get X equals to 8. There you go. I have my factors and I have my solution. So I'm good. All right. Lastly, I want to cover two problems before the video is done. Let's do 8 and then let's do 7. Let's do 8 together. First step is to find A, B, and C. So my A here is a 1 because that is the number in front. B would be my -13. And C is my positive 40. Now let's fill that in. B is -13. And my C is my 40. All right, now I want to look at numbers that multiply to make up 40. That adds up to make 13. Right? So this was like the last problem, correct? Okay, so we already know the answer for this. And we saw that this was factorable when we did it. We saw that this, after we did it, we got, I think, -5 here and -8 here. So we got X minus 5 and X minus 8. And remember, our choices that we did on our list was 1 times 40, 2 times 20, 4 times 10, 5 times 8, right? And we went through all of them, and we saw that 5 times 8 was the only one that worked. So let's do 7, all right? 7 is a very unique case. The number in front is a 1 for the A. The B is going to be -4. And C is going to be +24. Now you fill it into the diamond. What two numbers multiply to make 24? But adds to -4. Let's list out our possibilities, and here you can use your calculator. 1 times, so this is my list of factors. All right. We have 1 times 24, 2 times 12, 3 times 8, and 4 times 6. So let's try it. Okay. So I can try 1 and 24. Can I add them in any way to make 4? No. So that's not possible. Let's try 2 and 12. I know that they multiply together to make 24, so that's good. Can I add them? 2 plus 12? No. One of them has to be negative. -12 plus 2? No. What about -2 plus 12? No, that wouldn't work. Oh man, that doesn't work. Let's try 3 and 8. Okay, 3 times 8, that worked. That gets us our 24. We have to add it. 3 plus 8, Nope, that gets us 11. So that doesn't work. What about if I make 8 negative? Well, that gets me a 5. Negative 5. That doesn't work. What about if I make the 3 a negative? That gets me a 5. Oh, that doesn't work. Uh-oh. Still doesn't work. Let's try 6. So 6 times 4 gets us 24. 6 plus 4, that gets us 10. That doesn't work. What about 6 plus negative 4? Well, that's a 2. That doesn't work. Oh, man. What about negative 6 plus 4? Right? Or both of them is negative. Nope, that's negative 10. That doesn't work. Wow. It seems like we went through all the list of factors and none of them work. Why? Because this is considered to be unfactorable. Okay? Please understand that there are some problems that are unfactorable using this method. That's everything that you need to understand for factoring trinomials when a equals to 1, part 2.